13 on this sheet. So you've been making progress on it. Maybe you just don't feel comfortable that you're finished when you get there. No, those 12's one of them. Got a bunch of garbage here. Keep track of 3x squared minus 4. I'm going to put parentheses times 3 times x minus 3 squared plus x minus 3 cubed times 6x. So, you see anything in common?
Lots of 3's, lots of x's.
Alright, so one thing we kind of have to look at is we kind of have two terms in this. I know we got a bunch of stuff going on, but we've got this piece of our expression that's all multiplied together, and then we got this piece that's all multiplied together, and they're kind of separated with this plus sign. So we want to look to see what we have in common with this big piece and with this big piece. So, all right, so we definitely have an x minus 3, and it is squared because we've got squared here and cubed here, so we'll take out the smallest one. Let's see anything else? Let's see one more little thing. 3. Yeah, we got a factor of 3 because we've got a 3 here and a 6x here, so we can take out a factor of 3. And I'm just to help us keep up with where everything's coming from. I'm going to use a bracket instead of parentheses. So we've taken the 3 and the x minus 3 squared out of this first one. Just with 3x squared minus 4. And then we've taken 2 of these away, so we've got just x minus 3. And we took a 3 out of 6x, so that leaves us with 2x. And I guess we could, as far as factoring, I think we're finished there. We could distribute and combine like terms here, and it would just depend on where we're trying to get on the problem, what we would do. Yeah, but I think that's something nice we can do. So let's see what happens. So I just switched the order there. And then in here we got 3x squared minus 4. We distribute 2x times x, 2x squared. 2x times negative 3 is negative 6x. And then nothing too remarkable happens here. We combine like terms. We've got 3x squared plus 2x squared. So minus 6x. Nothing real aggressive or anything. It's just messy. And so it's really okay to leave it here. Give you a second to look at 13. See if you make heads or tails of any of that. Just another messy one. Really messy one. 13 just looks kind of like they tried to make it annoying just to be annoying.
Definitely did.
Alright, so basically I had two big messy terms up in the top, one term down in the bottom. Just looking for what we have in common there. So, I guess we can go ahead and get a factor of 3x plus 1 out of the way. Here, I'll copy it. We got 4 times 2x minus 3 cubed times 2, so I'm going to go ahead and multiply 4 times 2 and get 8. And again, we got 2 times 3, so make that a 6. Fun times. Let's see. What can I do here? Got one factor of 3x plus 1. We can take it out so we can get rid of one of those with one of these. Leave this with. I'm just going to switch the order and put the 6 in front here.
When you canceled out the 3x plus 1, why is it 3?
Okay, so yeah, I kind of did 2 steps at once. I shouldn't have. In the top, I'm factoring out a 3x plus 1. So that gets rid of this one and takes away one of these. Or puts it out front. And then I'm canceling the one I've got it on top with the one in the bottom. That makes sense. I got lazy and did 2 steps there. Get some smart.
Can you factor out a 2?
Yep.
At the top?
Yeah. Should be able to, and you can really do a little bit better than that, right? Because we've got this 2x minus 3 and 2x minus 3 here. So we can factor out 2 times 2x minus 3, and the smallest one of those we have is the third power. And that's just really messy from there. Times 3x plus 1 minus 3 times 2x didn't really accomplish a whole lot for us. Unless I'm missing something, I don't really see anything all that beneficial for us to do. I think we should be at 4, not at 8. That's kind of why I say that problem is just annoying for no good reason. So that didn't feel satisfying. Don't stress over it. Okay. And then don't worry about 14 on there. We're not a business calculus class, so we don't have to worry about some of the business formula. Get all of those? 12 and 13 are just not all that exciting. They're messy, but they're not exciting. So. Even in the math sense of being exciting. Okay, so this. We'll get some other problems here. I'll just write them up here. And so these are just solving by factoring. And so some of them will probably be really easy to use, especially if you've been keeping it fresh in your memory for ACT and things like that. So, when's the last time you got to take the ACT? When was it? June.
I learned like last December.
Yeah.
Yeah. Okay.
Well, I was supposed to take it in
March-ish.
April, and they canceled that one. And then June, Jacksonville's the only one that did it around here. And then July was canceled. My score stayed exactly the same.
Did it?
It was still full service.
My highest score was the first time I took it, so that was kind of disappointing.
I know a kid took it like his first time his junior year, made it 34.
I didn't do that.
It was a breeze for him. School was way too easy.
All right, so let's just look at an easy one. Make sure I get the sign right. I don't mess this up.
You can just stop at X squared.
Yeah, we could really start with easy go. So our goals, we want to be able to solve these by factoring. Just do stuff you've done before. We just want to get it kind of back to the front of our mind a little bit. So, how do we go about factoring one like that? What are we looking for? Do you remember?
Yeah, I remember
Right,
there's
we were taught it was
something.
like a little chart, right?
Yeah.
There's like a chart and you do something with lines and
You use the first term and the last.
Okay, so you can do it that way. On this one's kind of a special case because our leading coefficient out here is a 1. So that makes it a little bit easier. And if it's not a 1, you would multiply the first term and the last term together. And since that's a 1, then we're just multiplying by 1 and we get 18. So what we end up with, we're trying to find factors of 18.
yeah, because don't you want to? I guess if there was something in front of the x, like you would want those two to equal the -9.
Yeah, that's right.
Okay. And it is something like on the outside.
Yep, you're right. So here though, we're just ending up with 18, either way you think about it. So we want factors of 18, when we add them together, we get -9.
-6 and -3.
Yeah.
-6 and -3 work. Multiply the two negatives together, we get positive 18. If we add them, we get -9. So that works. So what's our next step when we find our two magic numbers?
X minus 6 times x minus 3.
That's right. So we write it down in factor form. Make it equal to 0, and then we did a little bit of this last time. I think we split it up into two equations. We have potential for two solutions here. One will get x equals 6, or the other one will get x equals 3. Will that ring a bell? So I'm gonna come back to you a little bit. Okay. So let's do another pretty easy one like this. I'll let you do it. So on ones like this, the hardest part is finding the two magic numbers, right? To find the two factors that add up to get what we want. Pretty much the same type of problem, just different numbers. Now when we're looking for factors of 4, go ahead together and give us positive 5. So what numbers work there?
4 and 4.
Yep. Plus 1 plus 4. And then when we split it up, you don't have to necessarily write it out every time as long as you know what you're doing. We get -1 and -4. Third on those. Alright. So let's look at one that's a little trickier then. It's nice when you got that leading coefficient of 1. It makes things a little bit easier. So what's different if our leading coefficient is not a 1?
You add the two numbers, or like the 15 and the 4, -4, or multiply.
Yeah, on that track, we're gonna multiply them.
Okay.
Multiply them. So what we're taking these two, multiply those. So 15 times 4 is 60. So -60. And I like to keep the variable also. It's just a good habit because if you have to factor things with more than one variable somewhere later down the road, that's a good habit to have. But it'll be okay if you don't like that also. But I keep my variable there with it. And then, now what did you learn? Because there are a bunch of different ways you can go on these. Anybody remember what method you used the last time you did these?
It had some kind of chart thing, I don't remember.
I don't remember doing that. I just remember doing the chart with the 15x squared and negative 4.
But she taught us another method as well.
Do you want me to show you what you did? So we did like,
There's so many different ways to think about it.
we did the chart for all of them. We may have done that once just to show us another way, but she normally did like, which my handwriting is awful.
Okay.
And then you have to find the two factors,
Mhm.
like the, and then this one works out to be. I haven't written on one, so. And then two, and then
So you-
multiplying together, it's negative 6x, and then you add it with 10x, then it comes out to be 4x, which is the middle term.
Yeah, all right, so when you got here, you
You want
cross multiply, okay.
so it's like,
Yep, I got you.
and then when you add those together, it's 4x, and then you just substitute two things.
Okay.
And then you solve them.
All right, so no problem. Okay. No problem with doing it that way if you want to do it that way. It's the same thing as this, it's just you don't have to multiply that, so that saves you that multiplication step there, so that's nice. The way I learned it in high school was using a box. Like I would have negative 60x squared in that box, and then minus 4. Oh, wait. That's not right. Been a long time since. I'd have 15x squared, so it's going to be similar to minus 4 here. And then I've got to find these two numbers to go in here, and then you factor out the greatest common factor on the rows and columns, and you get your. The way I usually teach it now is we're multiplying them together, and then we're looking for factors of this that will add together and give us the positive 4. So you can do that any way you want to do it. I mean, this is finding those. So yeah, positive 10, negative 6. That's right. So once you get these, whatever route you take to get those, then I rewrite the middle term as those two numbers. So instead of writing plus 4x, I'm going to write minus 6x plus 10x. That would be my next step. And then the nice thing about that is you can factor by grouping. So you look to see what you got in common with these two terms. So what we got there? We got a 3 and a x. 5x minus 2. And then we got a 2 in common here, a positive 2. So 5x minus 2, and then now you got the same thing in both sets of parentheses, so you can think about factoring that out. You got a 5x minus 2 times 3x plus 2. And then you can set each one of those equal to 0. So once you find these this way, what would you do next?
You take we just skipped all of those steps that you just did. So like you would cross multiply it, and then you get 5x minus 2 and 3x plus 2, and then you go equal 0.
Oh yeah, no, that's good. I like that.
Yeah, there.
It's more efficient.
Yeah, so the challenge on that is finding these. That way, when you
Yeah.
cross multiply, you get that. Right?
She would give us some that would take us forever to figure out the magic number.
Okay.
Yeah, because you do like an X and then like you circle across and those.
Yeah.
Yeah. Okay. Well, no, I like that though because you do. Let's see.
Which I don't even circle across. I do that
I just kind of multiply across in my head or.
Yeah, that's what I do. Cause I don't like marking over the
And
numbers.
then, yeah, then it's just, what, the numbers that you have are different.
And this way is the same way I like it with the box though, where I like once you get to -6 and 10x, then you're just doing the same thing. What do I have in common here? I've got 3x. What do I have in common here? I've got the 2. I get 3x plus 2.
I wanna say that she showed us a few different ways that people like would do it.
Mm-hmm.
That might have been one of them.
Any of those are okay. We won't have to do a lot of that in here, but being able to do them some way is really useful for ACT. You know. They like those problems. Okay. So that's a different type of factoring. We actually did this a little bit last time too. We mentioned it at least. Something like that. Well, we got 2 terms. Without factor, how do we do it? Difference of squares. Difference of 2 squares, that's right. So x squared is a perfect square, 64 is a perfect square, and we're subtracting, so we've got a pattern. Our pattern says if we've got a squared minus b squared, a plus b times a minus b. So this will be x plus 8. X minus 8. If we set both of those equal to 0 and solve, we get 2 solutions. So difference 2 squares. Let's see what else we got in here. I don't think I've got a good. I don't have a good cube on here. Let's find this one. That's something else good to think about for ACT stuff too, just to refresh. Am I freezing anybody out? Anybody freezing? Okay. I know a bunch of you got rained on. I didn't want to. Did anybody see it? Okay, so these are just other patterns. These were always, when I was in high school at least, these were always really hard for me to remember the pattern. I've learned better ways since I've got older. So, well, now think about if we've got what we call the sum of 2 cubes, we're adding 2 perfect cubes together, or if we have the difference of 2 cubes. These will factor. And they look really similar, and it was always hard for me to not get them mixed up. Anybody remember them?
Vaguely. It's like,
Seen it before,
It's
but
like A plus B times
yeah.
3.
I know you do like, cause like you're talking about like it's hard. They're like opposites of each other, so you do something where it's like the opposite sign and then the same sign and then the opposite, and it's just like I like vaguely.
So they're
So,
both
yeah.
they're both gonna look like this. We've got an A and a B in the first set of parentheses, and then we got A squared, AB, and B squared. And then it's the signs
Yes.
that'll mess you up. So for the signs, you need to remember. So the first sign is going to be the same as what you started with. So this one we had sum of 2 cubes, so this is going to be A plus B. So the difference is 2 cubes, so this is going to be A minus B. The next sign is going to be the opposite of what you started with. So here we started with plus, so this is going to be minus. Minus, so this one's going to be plus. And then AP. That one kind of goes together. That one's always positive. So this last sign is just always a plus. So to me, you remember what they look like where you got AB and then A squared, AB, B squared. I could remember that part, but I couldn't get the signs straight. That's so. That's with that. I think so. How do we use it? That's the difference of 2 cubes. 8's a perfect cube, x cube's a perfect cube, 27's a perfect cube. Difference, so we're going to use the bottom one. What do we end up with? Got A minus B, so A is just the cube root of this first term. Right? Cube root of A is what? 2, and the cube root of x cubed is just x, so we got 2x. Same sign as we started with, so minus. And then what's the cube root of 27? 3. And then anytime we need A and B, we can look back here. We don't have to think hard anymore on those. So we want A squared, so we do 2x squared, so it's going to be 4x squared plus our opposite sign. A times B, so we got 2x times 3, 6x. B squared, so we squared 3. And something that's really nice about these two patterns is that whatever you end up with here, it won't factor again. You don't have to check it. Okay? Once you get it from here to here, you're finished factoring. This always looks really tempting, like maybe I should check that to see if it'll factor again. It won't. You don't have to spend any time on checking that. Questions on those? So, how did Friday go? I know you said that was your light day, and I asked you how Monday went, but
I
Okay.
don't remember Friday.
you don't even remember it.
Friday was
Friday.
good.
Yeah, Friday was
Good
good.
day.
I think all the even days are gonna be my favorite, just because we don't have as much.
They're shorter.
Around and,
Yeah. That's good.
and they're classes that go